So let's see if we can do one more example here. We can take cyclopentanone and react it with this amine, the secondary amine. So after step 1, we're going to convert it to an enamine. So the nitrogen takes the place of the oxygen and we get a double bond. In this case, it doesn't matter which side it goes to. This is an enamine, this is a nucleophile. And so hopefully we're looking for some kind of electrophile now. Our electrophile in our second step is benzoyl chloride. So how can we bring those two together? Well, here's our alpha carbon. So we can have our lone pair come down and our pi bond come out. And then, do we lose the leaving group? No, we don't lose the leaving group. We break the pi bond and go up here. Remember, every time we attack a carbonyl, we break the pi bond. Okay, and that kind of brings us to this complex structure here a little bit. And we have an acid chloride that we're reacting with. So what happens when we break that pi bond to the carbonyl? This intermediate's not very stable. This is most definitely a CTI, a charged tetrahedral intermediate, with a very good leaving group attached to the O-. So for sure this oxygen is going to come back down, reform the carbonyl, and kick out that leaving group. So always with a acid chloride, we do addition elimination, we do substitution for that excellent leaving group. So that would be a way of installing this acyl group to the alpha carbon. That's pretty handy. And then our last step here, we're going to do hydrolysis. So an enamine is something that we create temporarily to use and activate it and make it like an enolate, and then we take that nitrogen back out. So that's what makes it a synthetic equivalent. So step 3, we're going to do hydrolysis. And hydrolysis of an imine gives us back our carbonyl. And that would be a very nice way of doing this transformation. Instead of using LDA and the very reactive enolate, we can use an enamine instead and do react it with an acid chloride electrophile in this case. That wraps it up for our second part of Enols and Enolates. Thanks very much for visiting Educator.com.